Welcome guys, today we're talking about special angle in trigonometry. We all know that trigonometry is the study of triangles and its properties. So today we're talking about special angles. Now, what comes to your mind when you hear special angle? The meaning of special angle simply means angle you can easily get without going through rigorous step that you can easily get by just checking properties of field shape. You can easily derive. So what are the special angles we have? We have the angle 0, the 30, the 45, 60 and 90. Again, 0, 30, 45, 60 and 90. Now for this special angle, they are sine theta and the tan theta. And in the previous class we've talked about trig ratio. Remember we have three basic trig ratio, although there are more than that, but the basic three we have is just that. So we're talking about how to derive angle 45 now next class, now next video. Okay, now we're talking about angle 45. Now you can see the illustration given there. Said given a square of length 1 unit, meaning we assume that the length of the square is just 1 unit. From what you see there, you can see that the person drawing the chart there measured the square to be about 3 or 4 centimeters or so. But we are just assuming that the length is 1 unit for now, and it doesn't really matter if it's 4, if it's 1. 4 is still like 1, meaning 1 times 4 will still give you 4. It's still in the same shape. So we just assume that the length of the square is just 1 centimeter. And in a square, what are the basic properties of a square? Let me bring you back. A square is a quadrilateral, right? Then a square, each of the angle of a square is at right angle, which means the each of its angle is 90 degree. And another thing we have again is that all sides are what equal. So if you say that a square of length 1 unit, that means all of the sides are what length 1 unit. Now, since we've already known all this, if we should bisect the square into 2 equal parts from the diagonal, we bisect it from the diagonal. The diagonal where we bisect is for, remember, each interior angle is at 90 degree. So when you bisect from the diagonal, the 90 you have at diagonal will be divided into 2 equal parts, and 90 divided by 2 will give us 45 degree. So that's how we come about the 45 degree you are seeing in the next diagram below. So now the two sides of the square in the new triangle formed. And how do you get a triangle? When you bisect the square into 2 equal parts, you should eventually get a triangle, equal triangle. Not equilateral triangle, like 2 triangles that are equal to each other, meaning like they are symmetrical. So that's that there. The triangle, in the triangle now, the diagonal of the square, that is the hypotenuse of the triangle, we don't know the actual length, but we know the side of each length of the square. So now how can we find the length of the diagonal, that is the length of the hypotenuse of the new triangle formed? We can easily do that by applying Pythagoras theorem, which we've learned in our previous class. And what is Pythagoras theorem? It is a theorem which says that the sum of the square of the opposite side plus the sum of the square of the other side is equal to the sum of the square of the hypotenuse side, which is the longest side of the triangle. So we're going to be applying that, and if we apply that by basic simple mathematics, we can see that our hypotenuse, which is the longest side, is tagged as x since we don't know it. Our opposite is given as 1. Our adjacent also over there is also given as 1 also as well. So all you just have to do is substitute in algebra. This is a basic algebra. So if you substitute, you discover that you have x squared is equals to 1 square plus 1 square. Then the next time you have x squared is equals to 1 plus 1. Then you have x squared is equals to 2. And we're not looking for x squared. What we're actually looking for is x. Meaning, what is that x? That's the length of the diagonal. So to find the length of the diagonal, we have to take square root from both sides or transfer square to the other side. So finding the square root of 2 is our final answer. So we leave our final answer in a short form. So that is whatever the square root of 2 is our final answer. So we'll be taking this figure to check for the sine value of that angle, the cos value of that angle, and the tangent value of that angle. Now to find the sine, cos, and tan is very, very easy. So since we already know what our SOHCAHTOA means, SOHCAHTOA, that is SOHCAHTOA. The SOH is sine is equals to opposite of hypotenuse, and the C is equals to, that's cos, is equals to adjacent of hypotenuse, and the T, that's the tan, that's T, tan is equals to opposite over adjacent. So we just apply this basic formula, then we get it. So when we have sine theta, the theta means the value, the angle. So now our theta here will be the angle we are dealing with. And what is the angle we are dealing with? The angle is definitely 45 degree. So we're working on our angle 45 degree now, sine 45 degree now. Based on this diagram we have below, shows the triangle in which one of the interior angle is at 45 degrees. So that means our angle in that triangle is what? 45 degree. So now sine 45 degree now. Since we have an angle 45 there, the opposite, the side facing the given angle is our opposite, definitely. So our opposite there is 1. then the longest side is x. And what is x? We find that earlier, that's square root of 2. Then our adjacent will be what? 1. So applying the formula, we'll be having sine 45 is equals to opposite all over hypotenuse, and what our opposite is definitely 1. Our hypotenuse longest side is square root of 2. So 1 all over square root of 2. We can't leave our answer there. We know we are not done at all. So the next thing we do is rationalize. You rationalize by multiplying by root 2 all over root 2, where root 2 over root 2 is still 1. And these are basic algebra. Also, I'm posting on some other video next week on how to rationalize, in case you have question on rationalization. So by simply simplifying the algebraic expression we have above, we later find our final answer as root 2 all over root 2. So cos theta, that's cos 45 now. Cos 45, applying the same procedure where cos theta equals to adjacent over hypotenuse. What's our adjacent? Our adjacent is 1. Our hypotenuse is what? Is square root of 2. So our sine value and our cos value is equal to each other, which is root 2 over root 2. Tan 45. Where tan theta is equals to opposite over adjacent. Our opposite there is 1. Our adjacent there is 1. Also 1 here. So 1 all over 1, that will give us what? That will give us 1. And also, there's an identity that says that tan theta is equals to the sine theta all over cos theta, meaning the tan of a given angle is equals to the sine of the given angle all over the cosine of the given angle. Meaning, if you say sine 20, I'm sorry, if you say tan 20, tan 20 is equals to sine 20 all over cos 20, meaning the value of what you have there. So you can simply do the same thing by dividing the answer for sine 45, which is root 2 all over root 2, divided by what's it called, the cos value, which is also root 2 over root 2. And you don't need to go through all those fraction aspects to get to arrive to your final answer. 20 divided by 20 is 1, 100 divided by 100 is 1. Since both the sine value and the cos value are eventually equal, so your final answer there too will be what? 1. So we've arrived at our final answer for sine, cosine, and tan. So for sine 45 we have root 2 all over 2. For cos 45 we have root 2 all over root 2. And for tan 45 we have what? 1. So we have treated the what? The angle 45 as a special angle. So the next slide we're talking about the remaining special angle. So see you guys. Okay, now we'll be talking about angle 30 and 60, deriving angle 30 and 60. The illustration given said given an equilateral triangle of length 2 units. So now the first question is, what is an equilateral triangle? An equilateral triangle is a type of triangle in which all sides and also all angles are equal. So if total angle in a triangle is 180 and all the angles are equal, that means the angle will be divided into three parts, since we have 3 angles. So 3 in 180, that's 60. Each of the angles is at 60 degrees. And we also from the illustration, they said the length should be 2 units. So the length of each side of the triangle should be what? 2. 2 units can be 2 acres, can be 2 centimeters, 2 units. We don't really care. So now going with the illustration now, the triangle you have below was divided into 2 parts. A perpendicular bisector was introduced. What do we call a perpendicular bisector? A bisector at 90 degrees, what we call a perpendicular bisector, meaning it divides the shape, and the angle at which it divides it is was 90 degrees. That means the line is vertically straight. That's upward, very very straight, meaning there's no slants. So the perpendicular bisector was introduced. Now if a perpendicular bisector is introduced at that particular place where the bisector is introduced, the angle too will be bisected. So the 60 you have also will be bisected. And don't forget, all the angles are 60. So one of the angles at which it bisected becomes what? 30, which we are seeing in the diagram. And also, wherever it bisects the triangle, that particular part is bisects the triangle, the side too is divided into 2 equal parts. So we can see that where we were having 2, 2, 2 before, we are now seeing 1. How does 1 come all about? Now, when the bisector bisects the triangle, it bisects the triangle into 2 equal parts. So when you have 2, if 2 is bisected into 2 equal parts, that means when you cut 2 into 2 equal parts, you'll be having 1, 1 on both sides. So the 2 shared into 2 equal parts, you're now having 1, 1 on both sides. So in the new triangle form now, we have 2, 1, and the unknown, which is x. How do we come about that? The initial side of the triangle is 2 centimeters, according to the illustration given. Then it was bisected, so one of the parts has been divided. So when one of the parts is divided into 2 equal parts, if it was 2 before, it becomes 1. If it was 10 before, it will become 5. So that's where we get 1 from. So that is clear. Now the next one is the x. The x, we don't know the value for the perpendicular bisector, so we call that x. And we can easily apply, what's it called? Algebra, simply algebra using Pythagoras theorem. So following Pythagoras theorem and solving the algebraic expression we have there, we get our answer. So by substituting, we're writing that the sum of the what opposite side, the sum of the square of the opposite side plus sum of the square of the adjacent side is equal to the square of the hypotenuse side. So when you apply that, you eventually arrive at the final answer, which is x is equal to the square root of 3, which I've done that in the next video. So let's just wrap things up to be very fast. So now our x is what, square root of 3, and note our x as square root of 3 does not mean that's the longest side. Now this particular example we are taking is a kind of example that is a little bit different from the angle 45. The angle 45 is a little bit straightforward. Why? It only deals with one angle, but this particular question deals with two angles. So when it's dealing with two angles, that means the opposite will varies. The opposite and adjacent will varies. Why does the opposite and adjacent varies? Simply because the side facing the given angle is the opposite. Now, if it's for angle 30 in that same triangle, for angle 30 in that same triangle, your opposite will be 1. If it's for angle 60 in that same triangle, your opposite become x. And as the opposite is changing, your adjacent will change, but your hypotenuse, longest side, will still remain the same. So that's why I had to draw two triangles. I draw a triangle for angle 30, I draw a triangle for angle what? 60, still the same triangle, but all I just do is I omitted 30 in one, I omitted 60 in the other one, so to make the example clear. So now let's just start with the angle 30. For angle 30, we can now see 30 is facing 1, so the opposite for 30 is 1 actually. Then the adjacent for 30 will be root 3, and the hypotenuse will be root 2. So we can easily find their sine value, cos value, tan value for angle 30. So sine 30 is equals to 1 all over 2. You can easily substitute when you know the value. What's the value of sine? Well, sine is equals to opposite all over hypotenuse. Then cos is equals to adjacent over hypotenuse, and tangent is equals to opposite all over adjacent. So by substituting, we have sine 30 to be 1 all over 2. By substituting, we have cos 30 to be root 3 over 2. By substituting, we have tan 30 to be 1 all over root 3. And if you rationalize, which I've done in the previous example, when you rationalize, you'll be having root 3 all over root 3. And for you to check more about rationalization, I'll post a video on rationalization, so we can easily understand more about rationalization. But in the previous example, which is on angle 45, I explained how to rationalize in detail, so you can also check that also as well. So moving to angle 60, for angle 60 we can see that there's a similar triangles, which is still the same triangle, but what happened here is that angle 30 was omitted and 60 is there instead of angle 30. So now the side facing angle 60 is root 3. So if side facing angle 60 is root 3, that means root 3 become your opposite. Then your adjacent is 1, where the hypotenuse remain the same. Then your sine value for 60 will be sine 60 is equals to root 3 all over 2 by substitution. Cos 60 is equals to